Hello guys, so today our topic is resistance. Okay, let's talk this. These are the topic for this is the lecture number 8 for today, and topics are resistance, factor upon which resistance depend, and specific resistance and or resistivity. Okay, so main thing is we are going to talk about resistance today. If you are first time to this channel, I want to let you know that this channel is on basic electric. We are making lectures on basic electrical engineering. Will make videos on basic electrical engineering concept. Will clear all the concept of basic electrical engineering, and we are uploading video continuously. Okay, if you are first time to this channel, I would like to request you to subscribe this channel so that whenever I will upload videos you can watch it first. Okay, this will help you obviously if you are a BTech student or a MTech student, or if you are preparing for any engineering job. This will surely gonna help you, because we are with theory we are doing numerical also. Okay, we are solving some numerical problem also after specific topics. Okay, so let's start. Resistance. What is resistance? Resistance is the opposition offered by a substance to the flow of electric current is called its resistance. The opposition offered by a substance to the flow of electric current is called its resistance. So suppose this is a wire, current will flow from this side, left side to right side, and this conductor has some power to resist or it has some opposition power. Okay, that try to stop the flow of current. Okay, flow of electric current, that is called resistance of any substance. Okay, some materials with good resistance are glass, rubber, dry wood. Okay, these are called insulator. Current can't flow through these materials. Okay, these materials has good resistance. These are called insulator. Okay, so the resistance is the electric friction offered by the substance and causes production of heat with the flow of electric current. It's same thing we are saying here. Okay, the resistance is the electric friction offered by the substance and causes production of heat. Okay, a resistance of a material or substance or anything, it produce heat. Okay, it produce little bit heat, or it depends on the material how much heat it's producing, but it produce heat. Okay, with the flow of electric current. The unit of resistance is ohm. Okay, here is ohm, and here is the symbol. This is the symbol. A wire is said to have a resistance of 1 ohm if it release 1 joule or develop 0.24 calories of heat when a current of 1 ampere follows through it for 1 second. This is one where current following through it, 1 ampere current following through it. There is one resistance is there. We'll say it has 1 ohm of resistance when when it release 1 joule, when it release 1 joule or develop 0.24 calories, 0.24 calories of heat. Okay, 0.24 calories of heat when a current of 1 ampere follows through it. Okay, for 1 second, for 1 second, then you will call that the wire has 1 ohm. Let's repeat it again. A wire is said to have a resistance of 1 ohm if it releases 1 joule or develops 0.24 calories of heat when a current of 1 ampere follows through it for 1 second. You can write down all these things and you can make notes. Okay, so you can repeat again next time easily. The factor upon which resistance depend. Okay, resistance depend on the resistance R. Resistance is denoted by R. Resistance depends directly on the resistance depend directly proportional is directly proportional to its length. Okay, resistance is suppose this is one wire, we assume this is one wire. Okay, so it's directly depend, length is L, length of this wire is length of this wire is L. Okay, so this the resistance depend directly on this L. Okay, it's that means it's directly proportional to its length. So R various L and is inversely proportional to its area of cross section, and it's inversely proportional to its cross section area of means this cross section area. Okay, this cross section area depend on it, or you can say inversely proportional. Okay, inversely proportional. So R varies 1 by A, R varies 1 by A, and depends upon the nature of material. Some material has like good resistance, and some are like they don't have resistance that much. Suppose copper has good copper has less resistance, and wood, dry wood, plastic, these are like plastic, these are like they are with high resistance. Okay, so current can't flow through plastic. Gold is with less resistance. Okay, gold is less resistance, so current flows through it easily. Gold less resistance. Okay, plastic, wood, and one more thing depends upon, and we said nature of material. Okay, suppose dry wood, if we talk about dry wood, dry wood is like it has high resistance. Okay, current can't flow through it. And if it is not dry, okay, if it is dry, it's not, if you put some water, on wood, then it become good conductor of electricity. That means resistance like decrease. Okay, depends upon temperature, and sometimes depend upon the temperature also. Normally it's depend resistance are directly proportional to temperature. Okay, normally it has so many factors also. Now specific resistance or resistivity. Okay, we have seen previously here that R is directly proportional to L, means length of the conductor, and R is inversely proportional to A, means inversely proportional to the cross section area of a conductor. So R is equal to, we can write R is equal to rho L by A, where rho is constant. Rho is a constant known as resistivity or specific resistance. So this rho is called resistivity or specific resistance. Okay, rho, RH, rho, it's a Greek letter. Okay, rho. So if L is equal to 1 meter, here if L is equal to 1 meter and A is equal to 1 meters 1 meter square, that means that the wire, this wire has 1 meter of length and the cross section here is 1 meter square. Okay, at this condition R is equal to, you can say R is equal to, here if we put 1 okay, 1 upside down, downside 1, so R is equal to rho. Okay, so specific resistance of a material is, material or substance or anything, okay, is the resistance offered by 1 meter length of wire of material having an area of cross section of 1 meter square. So the simple thing we are saying here, when a conductor has 1 meter length and the cross section of that conductor is 1 meter square, so that time we can say the resistance of that wire is like same to, is equal to the specific resistance or resistivity. So that's it guys for today. Okay, let's see, this is our this will be our next lecture, lecture number 9. In next lecture we will talk about conductance and we'll do some numerical problems and type of resistor. Okay, we'll talk about this. I would like to request you guys again, please do subscribe. Okay, we are uploading videos continuously and we are making small videos that gonna help you to, like, you will not get feel bored. Okay, you can watch, you can come one day, you can watch one single video 10 minutes 15 minutes or 20 minutes. It is like, by that, in that easy way you can revise your basic of electrical engineering, and this can help you for your BTech classes also and for engineering job also. Okay, so bye bye.